Hello, in this video we'll go over a similar postulate. We are going to see if we can prove if two triangles are similar. So yeah, a similar postulate. So this is one way of figuring out if two triangles are similar. So the shape of a triangle is determined by the measure of its angle. So that's something important. Yeah, so the shape of a triangle is always determined by the measure of its angle. Angle a similar postulate. So yeah, a similarity postulate, it states if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So they're not congruent, they're just similar. So let me read it again. If two angles, so if you have two triangles and two of the angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So, okay. So it doesn't mention anything about side lengths. It just says that if you have two triangles and two angles are the same from both of the triangles, I guess they are similar. So if you look at this this triangle ABC is similar to triangle KLM, because it looks like there's three angles that are similar, but I guess you just need two angles in order for two triangles to be similar. So this has all three triangles, three angles that are the same, right? You see this one tick mark? Angle K is congruent to angle A. And then do you see these two tick marks? Angle L is congruent to angle B. And then these three tick marks, angle C is definitely congruent to angle A. So in or triple A, the altitude are proportional. In similar triangles, corresponding altitudes are proportional to corresponding sides. So let's look at example one. Determine if the triangles are similar and if possible, write a similarity statement. So determine if the triangles are similar, if possible, write a similarity. So it looks like it, they're obviously not congruent, but as you can see, there's a minimum of two angles that are congruent. Angle U is congruent to angle L, and then angle V is congruent to angle J. Oh, that was given. So they said that given angle U is congruent to angle L, and I just looked at it, and then angle V is congruent to angle J. Is that all we have to do? Oh no, we got to make a statement. So I guess you could say yes. Um, Let me read the question. It says yes. You could say triangle UVT is similar. So as you can see, this symbol right here means similar, not congruent. Triangle LJK. Okay. Okay. Let's move on to the next one. Okay. In example two, it looks like we have these two. You see that there's two triangles. Uh, are these two triangles similar? I keep saying I want to say congruent, but no, similar. Um, I'm so sorry. I am missing information. This angle S is 16 degrees. Okay. So, are these two triangles similar? Um, so here's triangle one and here's triangle two. Yes, I see that there's based on the information we're given, you have angle S is congruent to angle G and then angle H or angle SHT. SHT is congruent to FHG. So as long as there's two similar triangles, I'm gonna say yes. And the reason it would be a similar. So yeah, you could say triangle TSH is similar to triangle FGH. Okay, let's move on to example question 3. So question 3, example 3, we have these two triangles. Let me see if I'm missing anything. I am not missing any piece of information. So what do you think? So here's triangle 1. Here's triangle 1 and here's triangle 2. Do you think they have two angles that are congruent? No, I don't. Uh, there, these two angle, this angle is congruent with this because vertical angle. So you could say, yeah, angle B, E, 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 C is definitely congruent to angle F, E, G, F, E, G. But if you look closely, angle C is not congruent to angle F. See how this has two tick marks? This only has one. So angle C is not congruent to angle F. We need at least two angles that are congruent. So um, definitely not similar. Okay, let's move on. Okay, example 4. Here we have, well, what do we have? It looks like we have two triangles. Here you have two triangles, and then you have these. You see that this side line segment RQ is definitely parallel to line segment VP, and then line segment RP is definitely parallel to VW. Um, that means that I think this is part of the image. That means that angle Q is congruent to angle P, and then angle R is definitely congruent with angle V. Also, angle P or RPQ is congruent to V angle VWP. Yes, I'm gonna say yes. Why? Why do I say similar? Because they have two angles. You see angle Q is congruent to angle P, and angle R is congruent to angle V. And then you also have the third one, but you just need a minimum two, so I'm gonna say yes. All right. So the reason is yes, A, or similarity. So you got QRP, QRP is similar to triangle PVW, PV. Oh, okay. So this is the reason why these two all these angles are congruent. See, if you extend these parallel lines, this angle is congruent with this angle, and then if you two parallel, so if you look at these two parallel lines, these angles are congruent with these angles. So this could be, this is geometry. Remember, this is the transversal line. I forget the reason. I think it's corresponding angles that makes these two angles congruent. So yeah, let's move on. So example, this one, find the value of x and y given as similar triangles. So they're saying that these two triangles are similar. Find the values of x and y. So x and y's are not angles, they're side lengths, right? So this, they do tell you that triangle ACD, this one, is similar to triangle EGH. Uh, this is E. Yeah, okay. So what we're gonna have to do is what else do we know about similar triangles? They have to have two or three congruent angles. And did you also know that their proportion must be the same? Or you could think of it as a scale factor. Okay, so how can we set this up? So we got to find the length of x and y. So this is the length of x right here, and then the length of y is here. So, okay, how I'm going to set this up, I'm going to set it up like this. Um, Maybe we could do AD and XH, right? AD or XH, so 7 over X, right? So I did line segment AD over line segment XH. And what else? I need to find. So now I gotta have two known values. I'm this was given a length H FH is 8. So can I do? Uh, oh, I could do this like DC, line segment DC goes with line segment HG. So DC is 9, and then HG is 12. Okay. Go ahead and cross multiply. So this will be, say, 7 over x equals 9 over 12, which can be reduced by 3. So 9 divided by 3 is 3. 12 divided by 3 is 4. And then cross multiply, so 7 times 1 is 28. 3 times x is 3x. Divide this by 3. You get 28 over 3. So another keynote, so x is 28 over 3, which is a decimal right now. Let's find y. Another keynote, if two triangles are similar, the altitude are proportional. Okay, so now we gotta find y. So we can set it up like this. Maybe we could do the altitude of dB, and then the altitude of HF. So dB is 9, 8. Wait, no, y, right? dB is y. And then HF is 8. And then this would be, um, we can still use 9 and 12. We could do DC over HG, which reduces to 3/4. So you could do 9/12 over 3/4. I'm just going to do 3/4 because I don't want to reduce. So what happens is I'm going to cross multiply. So this is going to be 4y equals to 8 times 3 is 24. Divide this by 4. Y equals to 6. Okay. Okay, let's go to example 6. It says that triangle WKR, triangle WKR is similar to triangle CPI. Um, we gotta find the length of Y, and we gotta find the length of X. So as you can see, if you examine the angles, two triangles, why are these two triangles similar? Angle 37 is congruent to angle K, and then angle 68 is congruent with angle W. Okay, so it looks like this is kind of like backwards, right? Yeah, the something is flipped because angle K is not congruent to angle C. Angle K is with angle P. And then angle C is with angle W. So how should we set it up? Maybe we could say like this. We could do line segment WK is goes with line segment PC. And then we could do line segment WR goes with line segment here. So be careful, this is flipped. So WR is the same with IC because this triangle is flipped. So what is WK? WK is 10x minus 6. And then PC is Y. And then WR is, whoops, I got it backwards. So it's really, so WK is 42. And then WR is 10x minus 6. Okay, remember when it said that if two triangles are similar, the altitude are proportional. So that means their altitude are the same. So what would be our I think what we need to do is that we can't solve it like this because there's an X and there's a Y, right? They're two different letters. So what we'll do is set each in proportion to its scale factor. So what would be a correct scale factor? So did you know? Yeah, let's set up a scale factor. So RK, you could do RK, maximum RK over uh PI. So RK is 56 and then PI is 24. And that could be reduced by 8. So that's going to be 7 over 3. So this is our going to be our scale factor. So what you could do, because we have two unknown letters, we can't just cross multiply. We'll just set each portion to 7/3. So starting with 42 over y, it could be expressed as 42 over y equals to 7/3. And then we can do IC is 36. So we could do 10x minus 6, 36 equals to 7/3. Okay, now we can solve for y and x. So over here, if we cross multiply, 42 times 3 equals to 7y. And then go ahead and cross multiply this, and you get y equals 18. Okay, so same thing here. Go ahead and multiply this out. So it's 3 times 10x minus 6 equals to 7 times 36. So 7 times 36 is 252. And then 3 times 10x times minus 6, that's going to be 3x minus 18. Add 18. 3x equals 252 plus 18 is 270. Divide this by x equals 9. Right? So this works. So this problem was a little bit difficult because we had to find two unknown letters. So what we could do is first set up your two proportion, and then you can set each proportion into equal to the scale factor, which we said was 7/3. Okay. Yeah, let's move on to question 7. Okay, so we have so they're saying that triangle PTS is similar to triangle KTL, and PTS. What do we got to do? We got to find out the side length Y and the side length X. Mm, we do this, okay? Uh, I keep the angle. They also said that angle P is congruent to angle K. Hmm. How should we set it up? Well, they're definitely similar because we just proved that two angles are congruent. Um, yeah, this is just like the other one where you have two unknowns, two unknown letters. So let's first figure out what could be our scale factor. So you can just say you could do this line segment PS over line segment LK. So line segment PS is 15, line segment LK is 10. That can be reduced by 5. So 15 divided by 5 is 3. 10 divided by 5 is 2. And then what you do is now set up your proportion. So we could say, uh, you could say this is a T right in the center. You could say line segment PT, line segment TK. It's equal to um, line segment ST over line segment TL. Okay, so then just fill in your blank. So PT is 9. Line segment TK is Y. TK is Y. And ST is, line segment ST is 12. And then line segment TL is RUT. TL is X. Okay, so as you can see, we can't just cross multiply because we have two unknown variables. So what we'll do is set each proportion to the scale factor. So you could say 9 over Y equals 2, and then you can say over X is equal to 3 over 2, right? So let's see what happens. So 9 times 2 is 18. 2 Y is 3Y. Divide this by 3. And we get Y equals 6. Here, 12 times 2 is 24. We'll say 3 times X is 3X. Divide this by 3. X equals 8. Okay, so that's question 7. Let's move on to- Here we have two triangles. What do you see the two triangles? You can say that this smaller triangle here, and then the main triangle would be the second triangle. So if you want, you can write out your two triangles. So the smaller triangle would be, sorry, this is B right here. So you can write that like this. So this length here is Y plus 8. Okay, so now what we could do is set up our proportion. So this length here was 6. This entire length is 6 plus 3, so that's 9. And let's see. it's going to be 6/9 equals to 12. Yes, so 6 to 9 goes with 12, and I don't know what this length is, so I'll call it X. And that equals to, we could do the hypotenuse, so you could say AE over AD. So that would be Y over Y plus 8. So as you can see, I think we have two unknown, two different letters. So what we're going to do is first we got to find the scale factor. So my scale factor will be, we could use 6/9, right? And that can be reduced by 3. So 6 divided by 3 is 2. And divided by 3 is 3. So we could say, um, we could find X, right? We could do this one, because this is just X. So yeah, let's do that. So 6/9 can be reduced by 2/3 equals to 12 over X. And then just cross multiply. So this is 2X equals 12 times 3 is 36. Divide this by 2. It's 18. Okay, so we found our X. Now let's find our Y. Um, so we could set this equal to our scale factor. So you could say Y over Y plus 8 equals to 2 over 3. And then I think yeah, then you would cross multiply. So this is going to be 3Y equals to 2 times Y plus 8. So go to multiply this out. So it says 2Y plus 2 times 8, 8 times 2 is 16. This is 3Y. Do solve for Y by subtracting 2Y, subtracting 2Y. So you get Y equals 16. Here, so we got Y equals 16 and X equals 18. So we just found our two unknown letters. Let's do one more example like this, and then we can finish off with two concrete. Okay, so here we have this, oh, this looks like some kind of triangle with a rectangle in it. Oh, and it says if Y, so let me write this down. I didn't write this down. If Y equals MN plus NP, 1/2, 1, 1/2 here, rectangle, M, MNDC, find X and Y. Okay, so, oh, I forgot to add this entire length from A to C is 12. And then, oh, it says if Y equals MN plus NP, 1/2 of the perimeter of the rectangle MNDC, find X and Y. Oh, so never mind. So Yeah, this was given from length segment BC, that's 5. Okay, so how is this going to help? NP. Um, NP. So if y equals mn plus np, where is y? Um, x. So if y equals mn, so this is what's given. If y equals mn plus np, one half the perimeter of the rectangle ndc, find x and y. So that means that np must equal to mc, which equals to 12 minus x. MC. We know that the length of AMC is 12. So maybe we should draw that way. See, it's 12. So this is X and this is W. So, oh, now, okay, so if this length is X and this is W, we know that X plus W equals to 12. So when you solve for W, it's going to be 12 minus X. Oh, okay, so that's how they got MC, just 12 minus 12 minus X. Okay, so now let's set up our proportion. So we could say X over 12 is equal to mn over 5, right? So y x 12. Yeah, x over 12, this entire length, is equal to mn. So what is the length of mn? Well, it's this rectangle. And as you can see, you have one tick mark here. So that means this is congruent with this. So uh, nm is also 5x over 12, right? So yeah, this is going to be x 12 equals mn 5. And then oh, okay. So now what I'm going to do is draw. So we have two triangle. We can draw our two triangles. If it makes it easier. I should have drawn that triangle. So let me draw. Let's draw our two triangles. So the first triangle I'm drawing is this triangle right here. If you see this triangle, if you connect this, if you extend this, it forms a triangle. So that triangle, and then the main triangle, this big one, is this. The length of AC is 12, and then the length of BC is 5. Okay, so we gotta find NM. NM. So what we could do is set up a proportion now. So we could say uh, x over 12 is equal to mn over 5. Okay, so we have two unknowns. X, so this length AM is X, and then is equal to A C is 12, and then MN is MN, and then we don't know what we C is 5. So now what I'm going to do is cross multiply, so 5 times X is 5X, and then 12 times M, and 12 times MN is 12 MN, and then divide this by 12. So MN. Okay, so now we can find y. So we're trying to solve for y, which they said is mn plus np. So we just found mn, which is 5x over 12, and we also found np, which was 12 minus x. I guess that's it. We oh, if you could simplify this, yeah, you can combine the x's, like you can 5x over 12 minus x over 1, and then find the LCD, and you get negative 7x over 12. And then you have the constant 12. You could leave it like this, or you could say your final answer would be y equals negative 6, 12 plus 12. Yeah. Last one. Let's do a proof, a two-column. So complete the two-column proof given that line segment DC is parallel to line segment BC. Triangle ADE is similar to triangle ABC. So let's write a two-column proof, and we got to prove that triangle ADE is similar to triangle ABC. So how do we know? How do we prove two triangles are similar? We got to first prove that two angles are congruent. So it looks like we have two angles that are congruent. So let's see. So let's write our two-column proofs. Statement. So we always do write out your givens. So my given is line segment DE is parallel to line segment BC, because that was given. And the AED is congruent to angle AC. Oh, okay, mm, so one angle is congruent. So we could say angle AED, this little tick mark right here, angle AED is congruent to angle ACB. This little tick mark here, because see how they have one tick mark? That means they're congruent. So that would be angle ACB. And the reason is because when you have two parallel lines that cut by a transversal, then corresponding angles are congruent. So yeah, so the reason is two parallel lines cut by a transversal will correspond to equals. And then we need one more angle. So if you could say third reason, if you want to draw two, you see that there's two triangles. Let me draw the two triangles. So this first triangle, I think this would be the first one. That would be like this. And then the bigger main triangle would be. Okay, so the reason why these and you say angle A is congruent to angle A, and the third that would be reflexive property. Last statement basically proving why. The last statement is triangle ADE is to triangle ABC. And the reason why is because uh, a similarity postulate. Okay, that wraps it up for this AA for the section. AA postulate similarity. I'm gonna stop here.